Hello friends, in continuation of the instructional videos on this LS brand H100 inverter, today we want to talk about the analog output of this H100 inverter. As you can see, the H100 inverter has two analog outputs, a voltage analog output and a current analog output. The analog output A01. It's an analog output that you can use to get an output either as 0 to 10 volts or as 4 to 20 milliamps. But the second output, that is the A02 output, you can only have it as a voltage output, meaning only 0 to 10 volts. You can only get voltage from it, but how do we determine whether the analog output A01 is currently in voltage mode or current mode? The DIP switch SW5, which is on the control board of the inverter itself, tells us this. If it's set to the VO position, it means the analog output A01 is in voltage mode, and if the DIP switch is set to IO, it means this output is in current mode. So our A01 can be either in voltage mode or current mode, and we can set this using the SW5 DIP switch on the control board. We can specify whether this output is currently in current mode or voltage mode. Voltage mode is 0 to 10 volts and current mode is 4 to 20 milliamps. As for the second output, that means the A02 output is also in voltage mode from 0 to 10 volts. But the settings we need to make for the analog output of the H100 inverter are that we have to enter the OUT group. We said that in order to configure the outputs of the H100 inverter in general, we need to enter the OUT group, and there, whether it's a digital output or an analog output, we set the relevant parameters. So the parameters related to the first analog output, which is terminal A01, range from parameter OUT 0.1 to OUT 0.5, and for A02, which is the second analog output of this inverter, from parameter OUT 0.7 to OUT 0.11. But what is OUT 0.1? OUT 0.1 is AO. Mode. What does that mean? It means whether it's going to give you a 0 to 10 volt output or a 4 to 20 milliamp output. Based on what specific criteria is it supposed to give you these four bases, or 0 to 10 volts in particular? For example, if you set the output value of channel 1 to 0, meaning frequency, based on the parameter DRV20, that is the maximum frequency, it will give you the full 0 to 10V at the output. For instance, if you set the DRV20 parameter, the maximum frequency, to its highest value. At the value of 50 at 0 Hz frequency, the analog output of the inverter gives you 0V and at a frequency of 50. Since your maximum frequency is 50, at 50 Hz it gives you 10V. So for the inverter, in the IUT 0 parameter, you need to specify that this range from 0 to 10V or 4 to 20 melee. Based on what specific criteria does it actually give you the output, which is referred to as AVIC mode? There are also several other options available. You can choose depending on output current, output voltage, DC link, output power, or even torque configure the rest of the options as well, as needed. The next parameter, OUT02, is gain, OUT03 is bias, and OUT05 is constant. So what do gain and bias mean? According to the diagram you see, if you set your gain parameter in OUT02 to 100% at 100%, now that's based on frequency. Here, when your frequency reaches 100%, for example, if in DRV you have set 20 to 50 and your frequency is 50, if your gain is at 100%, you'll have 100% of the output voltage at the analog output, which would be 10. But if you set it to 80%, your frequency will reach 50 Hz when it gets to 100%. If the parameter you set reaches 100%, as you can see, since we set it to 80%, the output will be 8 volts. But what does bias mean? For example, suppose you want to have 2 volts at 0 Hz. If you set the bias to 20%, your output voltage will no longer be 0. It starts from 2 volts and goes up to 10 volts, but as you can see here, that's how the gain works in a way. Gain is kind of like our upper limit, where we want to determine what percentage of the output we get at 100%. For example, what percentage of 0 to 10 volts, or what percentage of 4 to 20 milliamps. And bias is kind of like our lower limit. Alright, but now we want to do an example together here in this instructional video. We want to set the output 0, 1 to option 0, meaning we want to set our mode based on frequency, so our DRV20 will be set to reference 0, up to the 10 volts that is given to us at the output. We set the output 0 to 2 at 100%, meaning at 50 Hz at the maximum frequency. We want to have 100% output, meaning 10 volts. The OTE03, which is our bias, that's 0%. Let's assume we want it to be from 0 volts up to 10. But how should we do the wiring? If you have a voltmeter and you connect it to the analog output of the inverter and want to measure it, you have one analog output for the user with AO1 and AO2. AO1, as we mentioned, can be either current or voltage, while AO2 can only be voltage. For example, I use the AO2 and COM terminals and I set it to a voltage based on frequency so that at the output, depending on the frequency, I get 0 to 10 volts at the maximum frequency. Okay, I'm connecting the common probe of the voltmeter to CM and the other probe to terminal AO2. Or for example, I want to use the analog output of this H100 inverter and connect it to the analog input of the S100 inverter. I need to connect one end to AO1, meaning the voltage output, and connect it to the analog input of the S100 inverter. So I should connect V1 and the common terminal, which is CM, to the CM pin, and that's how the wiring is done. Let's go to the device now, apply the settings we've learned together as a team, and test this feature in real time together. So, as we said, in order to set the parameters related to the analog output of the H100 inverter, we need to enter the OUT parameter group. Okay, we press the mode button and move to the right with the right key. To the OUT group, we told OUT01 that we are setting its mode. We're letting the inverter know based on what criteria it should provide 0 to 10 volts at the output. I hate it on the frequency, meaning according to the DRV20 parameter. What is DRV20? It's the maximum frequency. Here I've set the DRV20 to 50. I'm confirming it, which means it will give me an output of 0 to 10 volts corresponding to 0 to 50 Hz. 0 Hz equals 0V and 50 Hz equals 10V. The next parameter is OUT02, which this is our gain. I set it to 100%, meaning at 100% frequency I want 100% voltage, which is 10 volts. And I set the bias to 0, meaning it should start from 0 volts up to 10 volts. So now I'm giving a 50 Hz frequency to the inverter. At 50 Hz, it should give me 10V at the output. Okay, I'm starting the inverter now. The voltmeter is showing 3V. I'm connecting the AO1 and CM terminals. As you can see, my multimeter is now showing 10 volts because I told this inverter to give me 10 volts at a frequency of 50 Hz. Now I'm going to change the frequency value. At approximately 25 Hz, it should specifically output 5 volts. You can see that the voltage value that the multimeter is showing me and is 5 volts. If I stop the inverter, then the measured value will gradually go back down to 0 volts. Now again, for example, I'll set a frequency. I set it to 35 Hz and restart the inverter. You can see that the output voltage is changing, and right now it's giving me 7 VDC at the output. I used the AO1 and CM terminals and I set the DIP switch for the AO1 terminal to VO. That is, now my output is based on a voltage from 0 to 10 volts. I'm setting the maximum frequency again, so at 50 Hz it should again display 10 volts on the output,